responses thereafter. Okay, 3 minutes starts now. 22:36 at 22:39, close to 22:40. I will then tell you what is the deal. Given the sum of n terms is 4n squared minus 7n, find the 20th term of this series. Grade 12, if you are asking grade 12, we are looking at grade 12 sequence and series. And we are just reviewing because we've been doing the topic. Now it's just we're trying to just check if people still remember certain things before we move on to functions. Given s sum of n terms equal to 4n squared minus 7n, find the 20th term of this series. Find the 20th term of this series. 1 minute and 30 seconds have passed. You are left with 1 minute and 30 seconds more. Find the 20th term of this series. Okay, I see your guys' answers. Still the question says find the 20th term of the series. You still have time to answer the question. I see your various answers. I see your various answers in the comment section. Let me thank you for you guys writing your various answers. As I said, I will not confirm anything yet until everybody has written or have at least gone through the process of doing the problem and answering it in their own space. To be confirmed. To be confirmed. TBC. Thirty seconds left. Okay, thank you so much, guys. I appreciate you guys doing the problem. We can now officially look at the various responses in the comment section. So in the comment section, let me just go up a little bit. We saw that some said the answer is 1460. Okay, had a few people say that. I think there are 3 people that said that. Miss Zim said, or someone else said 149. In fact, 2 people said 149. We had another that said it's 92. Someone said it's 1460. Someone said substitute 20 and then get the answer on the right. Now, guys, look at the question once again. We are given what here? The sum of n terms. Not Tn, but the sum of n terms. The formula is the sum of n terms and it's 4n squared minus 7n. The question says find the what? The 20th term. In other words, they want what? T20. How in the world do we get term 20 from a sum formula, the sum of n terms of the series. Okay, now in the comment section, okay, it seems many of you initially, when you calculated the 20th term, you said take 20 and substitute in the place of what? Of n. Now guys, if we substitute 20 in the place of n, what in actual fact are we going to get? We are going to get the sum of the first 20 terms. If that is the only thing you are going to do, substitute into this formula and get the answer. The 1460 that you get, guys, is not term 20. It is the sum of the first 20 terms. Okay, are we together? So let us ensure that when we read a question, we read it and understand what is there and then what is asked of us, so that we do not in excitement answer a question yes with a substitution that we may think is correct but in actual fact is not the one. So those who said S20 and substituted S20 alone and got the value on the left as 1460 and concluded that is the 20th term, guys, that is an incorrect answer. All right, because they are not asking for the sum, they are asking for the 20th term. Had they said though, find the sum of the first 20 terms of the series, this approach would have been 100% substituting 20 in the place of n and getting the answer. Okay, so in the comment section, I can see now people are coming back to reality and they're like, oh, this question is that question where we ought to use a formula that is not in the formula sheet but is a formula that is important. Which one is that one? Whenever we want to find a term from a sum of n terms, we want to find a specific term for a sum of n terms, we need to ensure that we take that particular term we want to find, then we say the sum of n terms minus the sum of the one less number of terms for the series. This is the formula, Sn minus Sn minus 1. So in other words, what are we saying here? If we want term 20, we need to say the sum of the first 20 terms minus the sum of 20 minus 1, which is basically what? That's S20 minus S19. That is how we find term 20 using the sum of n terms, right? Unconventional. This formula, as I had said to the learners during December when I was busy teaching them, those who were joining my live lessons then, all right, I explained that this formula is not in the what? In the formula sheet, but we need to know it, because I'm telling you now, grade 12, it will come to bite you if you do not know it. So had we, for instance, been asked what is term 4 of this particular series, then we use the formula. T4 is equal to S4 minus S3. Had they asked us to find term 7 of this series, we would have said term 7 is equal to sum of the first 7 terms minus the sum of the first 6 terms. So you can see, guys, that this is the formula that we use in order to find a specific term for a sum of n terms formula that we are given, whatever that sum of n terms formula is for a particular series. So please let us not be not knowing this particular formula. So we can go ahead then and do that, and I'm sure you guys can do that very comfortably. Then T20 is equal to sum of the first 20 terms. So you substitute that sum of the first 20 terms into the formula. So you would simply say 4 into 20 times 20 squared minus 7 into 20. That's S20 substituted. You then minus what? 4 into 19 squared minus 7 into 19. Right? And of course, I'm using these brackets just so that I can separate what I get here. That value, I can get it separately. This value minus that value will then give me the actual answer that I need for what? For the first, for T20. Okay? I hope we are clear. Thank you so much, Kwabile, for the hot meals. Also, the 2026s, I appreciate them, all 11 of them that you had sent earlier on. Thank you so much for that. Okay, so term 20 then. Okay, you can just grab then your sweet, beautiful calculator and you can actually get that answer, you know, that you need for T20. And obviously, guys, we can go ahead and do that. You know, that's why you have your calculator. Calculator is there to save you in situations such as this, when you are really honestly like, you're okay, too much admin there, you know, too much admin there. So can say 4 into 19. That 19, we can close that bracket and square it. Then we minus 7 into what? The 19 there. We close and we close. We close twice so that we can separate that term. And when we punch it in, boom! 149. That is term 20. That is term 20, my good people. 149. Okay. Now compare 149 with that value that you had gotten initially. You know, those big values where we got the sum of the first 20 terms. What a difference in the values that we had gotten there. 1460 compared to 149. They are miles apart. Miles apart. Okay. Okay. All right. I just wanted to open up that session and just sort of like break the ice there with those problems so that we need to constantly revisit for the purpose of practice, for the purpose of practicing the concepts that we have covered. We need to constantly revisit the topic and practice. By so doing, we stay in touch with what we have learned. Okay. Functions, I have a quick question for you, grade 12s. How many of you want me to actually first revisit? You want me to first revisit functions based on what you've done in the previous grades? Okay, we need to have a vote here, because it's either I jump into functions for grade 12 and cover the concepts for grade 12 without going back and revisiting grade 11 and 10. All right, so I just need you to, in the comment section, comment and say, if you want grade 11 and 12, write down in the comment section and say, start with grade 11 and then do grade 12 at another time. Or if you want me to do grade 12 now, immediately, just write grade 12. Then I can use your comments to actually decide what I'm going to do. All right. Yeah, I think let's do it like that actually. Okay, Precious saying 12 directly. 2-6 is like grade 11. Bani Makele, start with grade 11. Etogutle is like 11. Kwabile is grade 12. Okay. Yeah, because your comments, they reveal to me also, so that I can actually be aware, alert and awake. So far, grade 12 is winning, because grade 12, oh, actually no, we have 3-3. 3 guys. We have 3 grade 12s, 3 grade 11s. 3 people are saying grade 12, 3 people are saying grade 11. So we are tied at the moment. VKBF boys has just made grade 11s 4-3. Now we are at 4-3. 4 grade 11. We have 5 grade 11, 3 grade 12. So it's 5-3 at the moment. Grade 11 is winning. 12 is losing. Oh, Bontle just added to the tally for grade 11. Now we have 6. Gene, VKB boys, you are changing. What is wrong with you? What is this? What manner of changing is this? So now it's 5-4. We have 5. 5. Shalefeng, we have 6-4. Okay, guys, we have 6 grade 11. We have 4 grade 12 now. Okay, so at the moment, grade 11 is actually taking it. And yeah, it seems like in the majority, even though the ratio here, 6 is to 4. 6 is to 4. Yeah, it seems like grade 11 does win. Unless the 88 people that are in this live are actually just ghost learners that are here. I want to now just go through the roll call and just check. You guys will be shocked. So many people in this live. We've got Bujay, we've got Kanye, Quiet, Ngwato Bani, he's Gondas Luba, Brandon Nell Shoni, Angela, okay, Koki, VS, we've got CD, we've got Inara Sultan, we've got Supi Songos, we've got Anesh Klo, Kabezo, we've got Nomtewo. Love is quiet as a dove. Right, and many more. But these people are silent. Maybe it's just ghost learners. It's like our schools. We've got ghost learners. All right. So grade 11 wins, right? Class of 27. Wait for your sisters and brothers. I'm gonna say second year varsity. You're killing me here. Second year varsity, my foot. You're gonna say second year varsity Ngwato. So Ngwato is just coming here for the love of the maths. Okay, guys, so yeah, I think they are actually, myself as well. 2-6, I think people will come here to the live and then they switch it on. They are in bed and they are sleeping and they just pass out. All right, so let's get into grade 11 then. Let's get into the grade 11. So grade 11, we have what we know as a parabola, or we call it a quadratic function. First thing, let's talk about the form of the function. The form of the parabola function is, what is it, guys? I'm going to write down what is the form of the parabola function. I think now we need to get people talking and discussing if you can. So if you feel like you want to rather talk and not type, you're more than welcome to guest request, and we can get you up here and we can just iron out affairs that are there. If it's discussion based, it's more appropriate, not this thing of me just, because I know you guys are not empty vessels. You are vessels that are full. Yeah, full vessels, full, proactive, and knowledgeable vessels. Okay. So, what form is our quadratic or parabola function in as an algebraic equation? Do we know the form? Yes, Kobile, what is the laughter all about there? I see the laughter with the hand raised up. Are you 2010, 2006 or salute? What in the world is happening there? We have varsity students here. 2006. Fresh tomorrow. I think tomorrow, my girl, tomorrow we'll pick up the content for grade 12 functions tomorrow. We'll get into it. Okay, we'll get into it more in depth. But I think for today, let's give this function things for grade 11 its time. I think it's only fair. Yeah, the thing is, my Kwabile, the thing is, Presh knows her stuff. I know her too well. That's the thing. She knows she's going to get super bored by revising these things, and I understand her. I know. Yeah. Okay. So the form of the parabola function is y is equal to ax squared plus bx plus c. All right. This is the standard quadratic form. Okay, the standard quadratic form. Okay, can also be stated in this way as well. We call this the vertex or the turning point form of the parabola function. Okay. Sometimes to get the standard form, we also have what I would refer to as the root form. Why do we say it's the root form? Because the factors here, x minus x1, x minus x2, when you equate y to 0 and then solve for x, you get the roots of this particular equation, or the x-intercepts, if you want to call it that. The x-intercept form. Okay. Grade 11 twe. Okay. Grade 11. In grade 10, your parabola function that you had was only in this form. Y is equal to ax squared plus q. Okay. Yeah. And that grade 10 function, your parabola, it was restricted. Okay. In that the y-intercept, and I'm going to explain these things here. The y-intercept, in other words, where the graph cuts the y-axis, that is where the turning point as well was found. So your turning point was also your y-intercept. All right. So that's why I'm saying that the function in grade 10 was restricted in that way. Okay. Restricted. Okay. So yeah, we're going to unpack this a little bit more. Okay. So let's come to firstly to this form here. Y is equal to a x squared plus bx plus c. Okay. Just a few things. A, just like a there and a there. When a is greater than 0, we witnessed that our parabola, which is a curve, is going to be concave up. When A, in other words, is positive, we say that there is a smiling shape. The function, the parabola function, exhibits a smiling shape. We say that it's concave up when A is greater than 0. In other words, we're saying A is positive. So that's what this A value points us to when we are referring to the actual graphical sketch of the parabola. The parabola is concave up. So that's when A here, A there, and A here is positive. So in all situations, when A is positive, the parabola is concave up. In other words, it's smiling. Because when you are positive, just generally in life, if you are positive and you are happy, what usually happens in your face is that we see a smile emerge. All right? Because A is what? Is positive. So this A, when it is positive, smiling face. When A is less than 0, in other words, when A is negative, the parabolic shape is not concave up, but it is concave down. When you are negative, you tend to be angry and sad. You are down. Okay. I hope we sort of like are internalizing this. So that is what we get from when the A value exhibits either a positive value or a negative value. We expect our shape to be as such. All right. Furthermore, beyond that, I need you to understand that here at the bottom, at this point exactly, we refer to this as the turning point. Or we can say it is the minimum, the lowest or the lowest point of the function, which is also referred to as the minimum. So when A is positive, the function has a minimum value. All right. When A is negative, the turning point now is not at the bottom, but the turning point is at the top, which would therefore mean we don't have a minimum, but we have a maximum. All right. The highest point. Okay. Now, when our function is in this form, to get the turning point, there is a formula that we use to get the turning point. Firstly, if you want to get the x-coordinate of the turning point, you are going to use this formula. X is equal to minus b. B for what? The b value, which is the coefficient of x, over 2 times a, which a? The coefficient of x squared. This is the a value that we substitute there. And when we substitute the b and the a value, we get an x coordinate for the turning point, which we can calculate and attain. Then guys, there's not only the x value of the turning point, there is also the y value of the turning point. All right, which you can get using this formula. Y is equal to 4ac minus b squared over 4a. Or if you don't want to use that, you can always substitute the x value you get here into. So you substitute the x value into the function, and you can get the corresponding y value. Okay, so this is how we get the turning point, guys, of our function if the function is in this form. Y is equal to ax squared plus bx plus c. Right? And rightfully so, as Ngwato is saying in the comment section, if using the formula is difficult for you, you can always complete the square of the expression, which is not something I particularly advise, okay, because we have a formula that we can always use to get the x value and the y value. But of course, there are situations that may need you to complete the square of the expression, as Ngwato in the comment section is suggesting. All right, we're going to look at some examples so that we can actually internalize all of this. But for now, I need you guys to first understand the concept of the function. What does the a mean? As I said, a tells us about the shape of the function. Okay. A is negative, we are said concave down. We don't have a minimum, but we have a maximum. And I wish to suggest, guys, that whenever they want the minimum, let's say they want the minimum value of the function, guys, it is not the x value which is the minimum, it is always the y value that is the minimum. So when you calculate the y value, that is your minimum value. If they want the maximum, same thing, guys, it is always the y value that is the minimum. The value you get for y is the minimum value. The value that you get for y is the maximum value. But if they want the value of x that gives you that minimum, then of course the value of x that gives you that minimum, or the value of x that gives you that maximum, this is how you would get the value of x. This is your formula to get the value of x, which gives you either a minimum or a maximum. But the actual minimum or maximum is this y value. We must understand that the y value, the actual y value, is this one, which gives you the minimum or the maximum. But the x value which gives you those is this one. Okay, all right, so I hope we are good there. Okay, the c you see here, the c value is the y intercept. The c, this constant that is there, is what we call for the function the y intercept. By that we mean where the function cuts the y axis. And let me be practical with this, guys. We draw a parabola function on what we call, okay, what do we call this, guys? With this thing that has a y-axis and a x-axis. What do we call this thing? Okay, what do we call this thing? We call this thing a Cartesian plane. Okay, it's got a number line of x values and it's got a number line of y values. Now maybe now when you look at this, you're like, okay, so that is why I was saying, if I am looking for the actual maximum value, then what am I looking at? It is me looking at the y values, right? At the top, the y value, maximum. At the bottom, y value, the minimum. So that is why we say it is the y value that either is the minimum or the y value which is the maximum of the turning point. Okay, the y value. So the y-axis is here, guys, and what you have here is simply a number line of real values. Okay, the positive values above the x-axis, the negative values below the what? The x-axis. The Cartesian plane is divided into what we call quadrants. We call this the first quadrant, we call this the second quadrant, we call this the third quadrant, and then we call this one the fourth quadrant. Okay, here, like I said, above this x-axis, because this is the x-axis, it's a number line where 0 is there, we call that the origin. 1, 2, 3, 4, and all other numbers between 0 and 1 which are real values. Okay, because we are not only looking at natural numbers 1, 2, 3, 4, we are looking at all other numbers in between as well, because they can be featured there. Okay, so the values of x this side are positive, 0 there is neutral, the y values here are also positive. So that means here in the first quadrant, your x values are positive and your y values are also positive. In the second quadrant, the x values, guys, are actually negative, because -1, -2, -3, -4, -5. But your y values are positive. In the third quadrant, your x values are negative, your y values as well are also negative. Okay, then in the fourth quadrant, your x values are positive whilst your y values are negative. So this is what we call, guys, a what? A Cartesian plane. And as I said to you, this is the x-axis. Above the x-axis, y is positive. Below the x-axis, y is negative. This is such an important thing. I don't know if people really internalize. Above the x-axis, y is positive. Below the x-axis, y is negative. On the right of the y-axis, x is positive. On the left of the y-axis, x is negative. Okay, so that's an important thing to internalize as far as your Cartesian plane is concerned. Remember, guys, understanding your Cartesian plane with its quadrants and various different signs for x, y, x, and y is important because, okay, it's important because when you sketch your function, you sketch it in accordance to the values that are available in the respective quadrants. So understand, guys, what I am just simply explaining to you, all right, as far as the Cartesian plane is concerned. So, guys, another thing, on the x-axis, everywhere on the x-axis, we say that y is equal to 0. I repeat, everywhere on the x-axis, if we are going to ask what is the y value on this line, the y value is 0 everywhere on this x-axis. So we say y is equal to 0 on the x-axis. What about the y-axis? Everywhere on the y-axis, we know that x is equal to 0. Right? As I said again, on the y-axis, x is equal to 0. On the x-axis, y is equal to 0. So everywhere on this horizontal line, we say y is equal to 0. We call that, guys, the x-intercept. The x-intercept is where y is equal to 0. The y-axis, we call that the the y-intercept. The y-axis, we call the y-intercept. This is where x is equal to 0. So if you remember, I said to you guys that the c value is the y-intercept. Now maybe you are asking about how. Let's go back to this function. If in this function we were to let x here and there be 0, what will be left behind? We let x here be 0. That will mean that this 0, x squared, will all become 0 because 0 squared is 0. Then 0 times a is 0. Plus, we multiply 0 with b, this also becomes 0. Then who gets left behind? It's going to be c alone. Hence we say that the c value is what we call the y-intercept. It is the value that we get after we let x be equal to 0. The value of c is what we get. But we get it by letting what? X be equal to 0. We get c. Y is equal to c when x is 0 for this particular function. Alright? So that's why we call c, the c value is the actual y-intercept. It's where the function will cut the y-axis. It's where we let x be equal to 0. Okay, so this is also important where our parabola is concerned. Now I'm going to just hang on a second here, hold my horses, and then ask from you guys, from what you can remember from grade 11 last year, what else is an important feature that we need to be talking about when we are talking about our parabola? So you can use the comment section and let me know what is something that we are missing. All right. Thank you so much, Tidos, for the 2026. Really appreciate it. Gift appreciated. Amen. Anything else that you guys feel is of value that we are missing? Right? We've talked about A. We've talked about C. All right? We mentioned something in conjunction to B because, of course, when we want the turning point, we use x is equal to minus b over 2a to find the x value of the turning point. Then we substitute that x value into the function that we have, and we get the corresponding y value, or we can use this formula and get y. Okay. Guato is saying point of intersection. Okay, we will get to that, but remember, I'm still talking about the individual function in and of itself. Individual function in and of itself, not necessarily other things, because remember, point of intersection has to do with when you have other functions. Okay. User 1, is the value of b always given? Okay. Now user 1, the value of b is not always given. All right. It's not always given. All right. It's not always given. not always given. So Basha, you're getting ahead of yourself there. If what I'm seeing in the comment section is the point of inflection, remember this is still parabola that we're talking about. So yeah,